Okay, so before we start, let's have a look at this reminder. So it says 10 minus 1 equals 1, right? Well, here's the thing. What does 10 actually represent? Well, let's look at it. This 1 means that you have rolled over your base. So this 1 is 0 because you're not iterating that base. So you've already rolled over your base once. Then you keep iterating this, you roll over your base, and now you're over here, and so you're at 100 and so forth. So here, our base is 2 instead of 10. So think about it. How can 10 minus 1 be 1? Well, it's because we are writing 2 the way we normally represent 10, because when you iterate from 0 to 1, if our base is 2, what happens when you go up from here? We have iterated our base once already. So that is how 10 minus 1 can be 1. It's actually 2 minus 1 is 1 because of what I just said about iterating your base. Because it's base 2. 0, 1. Binary 2 is 1, 0. So let's keep that in mind and go through these problems. Now this first one is 1, 1, 0 minus 1, 0. So in actuality, let's look at these things. Let's see. So this is your ones place. This is your twos place. This is your fours place. What is 4 plus 2? This is 6. So this is actually 6 minus 2. Now 6 minus 2 is 4. You learned that way back in first and second grade. Now, if we go back to second grade, you learned about something called subtraction by columns. Okay, addition and subtraction by columns. Now, you can do that with any base. Not only in base 10, we can do this in base 2 as well. So, what happens if you subtract 0 from 0? Well, you get 0. Subtract 1 from 1? Well, you get 0 there as well. And we subtract 0 from 1, so we get 1. So this is the ones place, the twos place, and the fours place. So, what is this? This is 4 in binary representation. So, this is how you do 6 minus 2 in binary. But that's a very introductory level problem. Let us look at something a little bit more complicated. 1, 0, 1 minus 1, 1. Ones place, twos place, fours place. 4 plus 1 equals 5. 2 plus 1 equals 3. 5 minus 3 equals 2. Now, let's do this in binary. 1 minus 1, that's 0. Now, here's where it gets tricky. 0 minus 1, well, we're not dealing with negative numbers now. So what did you do back in second grade when you didn't know the concept of a negative number? You borrowed. So here, we borrow this 1, and that's 0 because we borrow the 1. So now we have this 1 here. So this is 1, 0 minus 1. So we have a 1 here. This is no longer a 1, this is a 0. Fours place, twos place, ones place. This is binary 2. And so this is how, with the same carrying in the column that you learned back in second grade, you can do 5 minus 3 equals 2 using binary notation. And I hope you've gotten that, because the next one involves more carrying. 1, 0, 0, 1, minus 1, 1. Ones place, twos place, threes place, fours place. 4 plus 2, okay, 4 plus 1, no, sorry, this is the fours place, this is the eighths place, sorry, it was my mistake. 1, 2, 4, 8. That's how it goes when you go by powers of 2. I was on autopilot there, so I made a mistake. So 8 plus 1 equals 9. 2 plus 1 equals 3. 9 minus 3 equals 6. So now 1 minus 1 equals 0. Now, this is where it gets tricky because we can't just borrow from the 0, so we have to borrow from over here, just like we did back in second grade. And now that we have 1, 0, we have to borrow a 1 from this. And now that we have borrowed a 1 from this, we can go and put this 1 here. So, what we do is we subtract a 1 from 1, we get 0. Oh, sorry, 1 from 1, 0, we get 1. So 1, 0 minus 1 equals 1. Now we have a 1 here. This one's also a 1. 0. So, 8's place, 4 place, 2 place, 1 place. This is a binary representation of 6. So that is how we do 9 minus 3 equals 6 in binary representation. Okay, now my friend Travis here told me I should only do one more example, so I am going to do this one over here. I am going to do this last one. 1, 0, 0, 0, 1, minus 1, 0, 0. And I've chosen this last one because it has the biggest number in it. Because 1, 2, 4, 8, 16's place. 17 minus, this one is minus 4. It's 13. And by the way, just so you know, 13 doesn't have to be bad. Yes, it's the prime number that immediately follows 12, which is a super useful number, but that's not a good enough reason to hate the number 13, even though I can understand why. Especially because it's not exactly a unique number. I mean, it's not exactly a palindromic number like 11. So that's that. But anyways, I digress. So, we use the same column technique that we learned way back in 2nd grade. 1 minus 0 is 1. 0 minus 0 is 0. Now we have to do this double borrowing again. 0, 1, double borrow, 1, 1, 0, minus 1 equals 1, and then this one is a 1. So let's think about this. 8, 4, 2, 1. This is 13 in binary. And so there you have it. That is how you subtract in binary using the exact same techniques that you learned in base 10 all the way back in 2nd grade.